Today's webinar is entitled Digital Preservation, Storing and Managing Digital Collections, presented by Jacob Nadal. Jacob was appointed the Preservation Officer for the UCLA Library in 2008. Previously, he served as the Field Service Librarian and Acting Head of Collections Care at the New York Public Library and as Head of the Craig Preservation Laboratory at Indiana University. I'm now happy to introduce Jacob Nadal.
Thank you, and welcome everybody. This is the third in a four-part series of webinars about fundamental issues in digital preservation, and today we're going to talk about storing and maintaining files and digital objects. Like the other webinars in this series, and in 1 hour we can't make you an expert in this area, and we can't give you all of the technical skills needed to do storage and maintenance, but we can try to make you a savvy consumer and make sure you know what questions to be asking as you get involved in these projects, to have a sense of what's very important right now, what issues have to be dealt with soon, as well as issues and questions that can be left for later. So I'm going to talk through a couple things with you today. One are some sort of models for how we do storage and maintenance of digital preservation, and we'll talk a little bit about what we mean by digital preservation as opposed to backup, and talk about the difference between concepts for how a digital archive works and the actual systems that are implemented, the hardware and software that make them run. We'll also look at, in brief, at some services that people are using and some ways people are going about storing their digital content, and try to educate you a little bit to the pros and cons of those approaches. One way we talk about storing and maintaining files is by referring to something that we would call a digital repository. And a digital repository is sort of, in some ways, an abstract notion of a system that does these three principal functions. It ingests material, that is, it takes digital content into itself, and once it has it, it manages it. So it has something that it does to ensure that that content remains intact and usable over time. And finally, it disseminates the content of the repository. It makes those digital materials available to users. The sort of common denominator, or the way we talk about this across all different digital repository architectures, across different software and hardware systems, is the OAIS, the Open Archival Information System. This is something that was developed by the Consultative Committee on Space Data Systems, space researchers, to deal with their data storage problems. And you can imagine the pressures that exist when you're sending a probe into space. You really get to build it once, program it once, and then you need its data to be available for a long, long time. And so thinking through this process carefully is very important to that community. You'll see two links on this page. One is to the good old Wikipedia article, which is actually a pretty good summary of the OAIS, and then the other is to the very long, very dense document that articulates the whole framework. For our purposes, and for most of your thinking about digital preservation, what you really need to know is this high-level view that I have on this slide. The OAIS divides the digital repository process into three stages: producer, management, and consumer. On the producer side of that, producers create submission information packages. That's the SIP that you see on the diagram. A submission information package could be any number of things. It could be as simple as a TIFF file from your scanner. That could be something a little more elaborate, a group of 300 TIFF files and an XML file that describes how they go together to make a book. It could be yet more elaborate than that, a complex multimedia object with audio, video, text, images, all brought together by some sort of metadata wrapper. All that this diagram is really pointing out to you is that there's a production stage in creating digital content. And the output of that is the submission information package, the thing you ingest into your archive. That ingest process essentially consists of taking content from the producer and adding to it the administrative information you need to manage it for the long term. This could involve standardizing file names, It could involve adding additional metadata, things like the date a file was added to the archive, information about the file types contained in a digital object, information about the rights that apply to the object, the intellectual property considerations. And those, together with the original object, create the AIP, the archival information package. And that's the entity that's really going to be managed and preserved over time. You'll see in here several bubbles, one for preservation planning, another for data management and archival storage, and another for administration. We're by and large going to ignore administration today. This is just everything you would normally think of in the administrative world. And today we're really going to talk about archival storage primarily, and to a certain extent preservation planning and data management. Because one of the most important and fundamental things once you've taken content into your repository is that you have to write it to some sort of storage media. The OAIS doesn't know and doesn't care whether that's a flash drive, a hard disk, a tape in an LTO drive. We're going to talk today about some of the trade-offs there. But remember, the OAIS is an abstract model. Finally, I just want to give a nod to the consumer end of this, right? That the goal of all this eventually is to give this digital content to someone, and that's the consumer end. And that little bubble that says DIP stands for Dissemination Information Package, and that's the content that you present to your users. In the most simple and in some ways most common digital library situation, a submission information package is probably something like a TIFF image, a scan of a photograph with some metadata that's ingested into a storage system, which could be as simple as a file server maintained on your network. And probably you add some information to that, the date the file was added, a hash or checksum that is used to verify file integrity, some other metadata. And then the dissemination information package is the web version that you display to your users, a high-resolution JPEG, for example. I think it's important to make the comparison between the OAIS and the world of digital preservation concepts and core IT concepts. The OAIS and conversations about digital preservation touch on some things that are common in well-managed IT environments: database administration, system backup, and replacement of media. So at the point a hard drive fails, it matters just as much to an IT engineer as it does to a digital preservation specialist that media is replaced. It's important to digital preservation thinkers that content is backed up and replicated off-site. Likewise, database integrity is important for an archive's continuing usability. On the other hand, digital preservation has some concepts that are more specifically archival. And two of the ones that I think are most important to think about are preservation planning and metadata. Because in our world, we take a little longer view of this than we would need to do routine updates to a system or to do digital asset management the way that many people in the commercial sector do. And so for us, a designated community of users, an understanding of who will be using this material and for what purposes over a long time is really important. The designated community of users in, say, an advertising agency tends to move through and have a much shorter horizon for their use of digital content than humanities researchers or historians of science. Many of the same things happen. Content's created, it's managed for a period, metadata is attached to it, it's distributed to users. But the horizon over which we're doing that is different. The other important thing to remember is that we need to think about distinct granular information objects, some sort of information package. In the loosest form of backup, where the contents of a server are written, for example, to a tape drive, the independence of the particular objects in the archive can be lost. And this is an area where, for preservation purposes, maintaining the integrity of the particular object and the metadata that relates to it is very important to us. and may not be a concern of core IT. Don't hear what I'm not saying. There are lots of IT system administrators and lots of IT setups that involve backup that for all intents and purposes meets our need for digital preservation. But be aware that the two concepts aren't synonymous with one another, and that there's some margin for disagreement between them. In this next slide, I just want to show you a little taste of sort of the deeper level of the OAIS. This is one entity, that data management entity. If you'll look at this slide, you'll see the bubble I'm talking about. And what the OAIS does at length for each entity is it describes certain functions that belong to it. So for instance, a database receives database updates. It generates reports. It responds to queries. Likewise, in the archival storage entity, you'll see at the bottom a media layer, and you'll see certain functions attached to that, replacing media, error checking. You'll see that disaster recovery is handled by some sort of backup media. The OAIS does not specify what those media have to be, how those functions have to be performed. What it does is serve for you as a sort of checklist to make sure you've thought of all of the important functions in preserving an archive over the long term. And for that, it's very useful. And I think as you begin to think about how you're storing your content, as well as evaluating where there may be gaps in your service, you do well to start with the OAIS. Begin with the very high-level diagram and ask if you can tell yourself a story about how you ingest content, how you manage data and administer it, how you provide access, and then gradually drill down, look at each of those functions and ask if you have a process in place for doing each of these things. And gradually, as you work through that, you'll come to a more robust understanding of your own needs, and you'll also have more and more confidence in your system. In fact, what you'll be doing is building towards having a trusted digital repository. There's now a certification process that's been developed out of work that started in the research library groups and has defined some sort of core areas of accountability for someone who wants to call themselves a trustworthy digital repository. The first one of those is OAIS compliant. That is, they can tell that story I was just talking to you about how their systems, how their software, how all of the particular pieces they've assembled complete the OAIS checklist. The second is administrative responsibility. You need to know who's in charge of that repository, who's answerable. And the third is organizational viability. So an organization needs to have some sort of reliable structure and accountability to function. Four, it needs to have finances. They have to have a plan for paying for their operations. And fifth, they have to have technological and procedural suitability, which is really a way of saying that the technologies and procedures they've chosen are suitable to the content they're managing. If, for instance, they're claiming to be a great image archive, and you harken back to our last webinar, but they don't really have any way to manage color data through their workflow, they don't have suitable technology and procedures. On the other hand, if their claim is that they are a great audio preservation service, and they haven't thought about color calibration, it's not particularly important. Sixth is system security. If you talk to an IT administrator about all of the work that goes into just keeping hackers out of systems, you'll gain a new respect for your colleagues. And then seven, procedural accountability. Essentially, the procedures are documented and vetted by someone independent. Several groups have gone through a formal audit process. Portico is one that's probably familiar to many of you. They are an e-journal preservation service. They were audited recently by the Center for Research Libraries. Locks, lots of copies keep stuff safe, a project in journal preservation and other digital preservation activities that's based out of Stanford. They've gone through a sort of self-certification. They've gone through the what's called the TRAC checklist, the Trusted Repository Audit and Certification Checklist, and sort of self-certify to as preparation for a formal audit. All of that said, this has been a high level to this point, and I think it's important in these webinars that we take a little bit of time and kind of get down to the bare bones. And so what I'm going to do in the next couple of slides and through the rest of this webinar is try to step back and talk from the very barest sort of seat of your pants digital preservation and storage setup to some more advanced systems. Talk about how those systems kind of meet the needs of digital preservation, where they're successful, where they fail, and try to give you a picture of where you might fit in and where your needs might fall on this spectrum. So someone asked me once, you know, for about $1,000 was their budget. Was it possible to do digital storage and digital preservation? And we talked, and we came up with some answers. You know, we thought that, well, one thing was just that you needed to have multiple copies of files in multiple places. And by buying a couple of external hard drives, a terabyte will cost you about $200. It's probably $150 by the end of this webinar. You would have the ability to create 3 copies of a file. A hard drive is not a preservation medium. The lifespan of these things is safely 3 years, optimistically 5 if you're lucky, 7. But their concern was, you know, having $1,000 a year or so to spend on this, can we get from year to year safely and securely? And with 3 copies of a file, probably you'll do that. And then they would need some software, a text editor, something that could do XML, a PDF software package, something that could output the PDF-A archival standard, imaging software. TIFF was important, JPEG 2000, hopefully, something that supported ICC profiles, audio software. We knew that they wanted to output .wav files, which are uncompressed PCM sound data. And video, they were really interested in, but we really talked about how it would be wise to wait if possible. That uncompressed .avi video is the current safe bet, but the storage costs of that are tremendous. And we'll, in fact, in webinar number 4, talk about the sort of state of the state with audio and video. But for about $1,000, we felt like this would be viable. It's not anything that we wanted to go to the next International Digital Preservation Conference with and announce that we'd solved the problem. But we sort of thought, well, this is not digital preservation. This is at least good day-to-day, year-to-year maintenance. And we came up with this little plan that, you know, say it's January, you would attach one of those external drives to the workstation where you were scanning in your archive, back everything up, and then you would take it off-site and bring in drive 2, mirror the contents of those. By March, you would have 3 drives going. This chart we expanded to add a 4th. But working this way, you'd always have 3 or 4 copies of your work, and you'd never be at risk of losing more than maybe a couple of weeks of work. Again, it's not really first-class digital preservation, but it's the beginnings of sensible management, right? So it's a viable way of getting your digital content through the year. And I liken this to analog preservation, where if the question is, how do I preserve something? Well, the first thing is just to get it into a large, dry room. And the next thing you want to do is make sure that there are people taking care of that room. You know, something in someone's basement is much worse off than something in the archive's basement, just because there are more archivists paying attention. It's even better in the archive's carefully controlled warehouse, even better in its high-density off-site storage facility. But the first step is really to get something into good management. The other lesson that was important here was that we really don't want people to avoid digitization because they don't have a digital repository set up. It's a really important time for us to be investing in making our collections more accessible. And there's a lot of justified excitement about digital libraries. And digital preservation and digital repositories don't have to be an obstacle to that. That said, the other lesson we took away from this little exercise was sort of thinking we don't want to just keep on digitizing, and especially we don't want to promise long-term preservation without developing, or in the current likely scenario, contracting for a really more substantial repository. So when that step comes, when we want to move away from just bare bones, we have a lot of options available to us. And I'm going to talk in a little bit of detail about two of these systems that I think are becoming fairly commonly used and fairly easy to get access to, and then spend a little time talking about sort of more do-it-yourself approaches. The first one I'm going to talk about are Fedora digital repositories, and then I'm going to talk about LOCKSS networks. And I think both of these are excellent digital preservation systems, and they show sort of 2 points on the spectrum of how people are going about solving this problem. And both of them are available to you with prices that are fairly well known. Whether or not they're affordable is a matter of your own institutional budget. But I think both of these are within sight for most people. Fedora is a digital repository software, so it performs the back-end functions of taking in, managing, and returning data. And it does a couple of very important things. One is that it identifies discrete digital objects. So a particular digital object, this digital book, that digital photograph, this digital movie, have an independent, identifiable place in the system. The second important thing it does is that it asserts relationships amongst digital objects. And we'll look at this in a little more detail in a second, but it essentially lets you say that something is a part of something else, or that it has a certain relationship to another object. And then third, it links behaviors to digital objects. And this is something that's very important for long-term preservation, that we might have a behavior we want to attach to an object that says something like, resize this master image to this size and format for web delivery. In the future, we might want to have a behavior attached to an object that says, take files of this sort and migrate them to files of another sort. Also important about Fedora, it's open source software, free to use and develop on your own. Fedora-commons.org is the website that it's made available from. But it's also available through a fee-based service called DuraCloud. And what DuraCloud is essentially a product that takes Fedora, a back-end repository software, and integrates it with DSpace to create an interface to that repository. And DSpace, many of you are probably familiar with, is software developed by MIT, one of the first sort of institutional repository softwares to allow people to put their content together and aggregate groups of content for the web. The costs of buying into the DuraCloud service range between $4,500 to $7,000 a year. That gets you somewhere between a ½ terabyte and a whole terabyte of storage. And it costs about $1,000 per terabyte per year for additional storage on top of that. That $1,000 a terabyte is actually pretty comparable to what you would pay on the commercial market. And what you're paying for with the sort of initial price is all of the people at DuraCloud who set up, maintain, monitor, and continue to develop the software. And one of the important issues to sort out as you move into the world of digital repositories is the upfront out-of-pocket costs of paying someone to provide a service for you versus the internal overhead of running a service yourself. If you want to download, install, and configure Fedora from the open source repository, you'll save your checkbook a little bit of money, but you'd better have some time and a savvy programmer available to you to oversee that process. Fedora, just to point a little bit more to its depth, is based on the Kahn and Walensky framework, which essentially supports this notion of semantic triples. If you are looking to impress a computer scientist at your next cocktail party, this is a slide for you. A semantic triple is essentially an object described by metadata, or a page image that's part of a book. So it's an object that has relationship to another object. And these triples in Fedora are used to create well-defined, persistently identified bit streams or digital objects. And Fedora is essentially a very well thought out, very well built system for making sure that those objects are always maintained and keep their integrity. Fedora potentially can store those objects on any type of server. So DuraCloud uses a cloud-based system, which is essentially a lot of hard drives accessible over the network that are constantly being mirrored to one another so they can be easily replaced. Another sort of the granddaddy of cloud systems and distributed storage is the LOX network. And LOX points to this line from Thomas Jefferson to Ebenezer Hazard that really led to the development of the government printing office. Let us save what remains, not by vaults and locks, which fence them from the public eye and use in consigning them to the waste of time, but by such a multiplication of copies as shall place them beyond the reach of accident. And what a LOX network does, and LOX does this really to the nth degree, is to take content from one place and distribute it throughout a network of LOX participants to make sure that there are dozens, if not hundreds, of copies of that content mirrored and stored across a geographically very widely dispersed network, so that any one of what would be called a node, any one of those participants, can lose access or suffer a catastrophe, and the network as a whole remains robust. LOX started as an e-journal preservation service, the idea being that individual issues of an e-journal were harvested into the network, distributed across many LOX boxes, these LOX machines, and that those machines then talked to each other all the time, comparing their contents. You know, I have volume 3 of Journal of Fancy Research, who else has it? And everyone would compare their copies and make sure that, that they had matching content. This allowed LOX to do things very inexpensively. So LOX is built on commodity hardware, sort of desktop PC grade, which means hundreds, maybe thousands of dollars to provide for hardware. And then the LOX Alliance charges a fee, or in the case of private LOX networks that we'll talk about in a moment, they'll negotiate a price. And those range anywhere from about $1,000 from associate granting colleges, $2,000 for bachelor's granting colleges, up to about $10,000 for Tier 1 research universities, places like UCLA. And those fees support the ongoing development and maintenance of the LOX software, the software that essentially instructs these boxes on how to talk to one another and compare content. So LOX had its birth in, and still really is a solid and important part of our e-journal preservation infrastructure. It essentially serves as a specific digital preservation repository focused on that content type. The technology behind that and the content that's used in there don't have to be limited to e-journals, however. And over the last few years, we've seen a growth in what are called private LOX networks. And what private LOX networks do, and what's useful about them, is that they take the same advantages of a LOX network, lots of geographic distribution of content, mirroring of files, the ability for data to be shared across the system and constantly checked. But they close it off to a distinct group of participants. So they provide an extra layer of security and insulation. The standard LOX system really is fairly open. It crawls the open web. A private LOX network crawls a private network that's set up particularly for the purpose of digital preservation. So institutions in a private LOX network form a mutual aid system to maintain each other's content. Two of the private LOX networks that I think have received a lot of justified good publicity are Meta-Archive and the Alabama Digital Preservation Network, and links to their sites are available there. But there are many of these now, and the LOCKSS group maintains a listing of them on their website. The cost of getting involved in LOCKSS is really the cost of everyone having a commodity PC, of everyone buying sufficient storage, and then the cost of setting up and maintaining it. I think probably on the whole you come out somewhere in the neighborhood of the DuraCloud services initially, but the cost per terabyte of storage is much lower because you're buying commodity hardware. Finally, then I want to talk about some sort of third-party services. OCLC maintains a digital archive, and those of you who are using Content DM to create and manage your digital content may find this a really compelling service. I'm afraid I don't have good pricing information for them. But like other digital preservation systems, essentially OCLC is writing content to multiple hard drives so that any one of those fails, it can simply be replaced and content is mirrored onto it. There's also a lot of talk about cloud services. I mentioned this in passing earlier, but I want to say it again and maybe in a little more depth now. The cloud is simply a metaphor for a way of doing storage management. In a cloud setup, you, a local user, connect to the network, and that network connects you to a cloud storage system. And what that is essentially, in real hardware terms, something that's called a RAID array, a redundant array of inexpensive disks, so that there are many, many disks set up so that the same content that you send them gets written to multiple copies, multiple instances of disks in that RAID array. The benefit of that is that if one of those disks burn out, and they burn out all of the time, the system administrator removes that disk and installs a new one, and then the system writes content back to that disk. So you're never dependent on a single piece of hardware, on a single copy of your files on a single disk for data integrity. You always have multiple copies. Know, though, that the cloud is not inherently geographically distributed. In fact, there's a wonderful IT history blog, and one of the editors of it posted a photo one day of the road that leads to Amazon's cloud at a data center way out in a rural part of the United States. So that data center itself will have multiple copies of your file stored in parallel, but the data center itself is not then necessarily backed up to a second geographic location. So if you're thinking about cloud services, it's important to talk to your provider and understand exactly how their cloud gets created. One of the risks that we think about when we have a 30 or 100-year planning horizon for our content is a major flood or a tsunami or a hurricane, an earthquake, and those are geographically focused incidents. Clouds are great for day-to-day reliability, but just like anything else, they're prone to the perils of natural disaster. Using a cloud service also is going to require some level of on-your-own software development. So cloud service providers will give you essentially a big box to put things in, but it's up to you to organize content within that box in a useful way. You could do that through dedicated digital repository software, something like DSpace or something like Omeka. You could do that with just a simple FTP client and a set of operating instructions for a human user. You know how your mileage varies with those different options. Software is great for enforcing control, but you have to maintain and develop it. Humans are great for getting something started, but they're also prone to making a mistake at, say, 4:59 on a Friday afternoon when they're renaming files on the server. Two commonly discussed cloud services in our world are the San Diego Supercomputing Center and Amazon. Amazon Web Services provides a simple storage solution, S3, and their costs when all the math is done is about 1,000 terabytes per year, something that should ring a bell to you from the DuraSpace costs. San Diego Supercomputing Center provides a storage and backup solution as well at a less expensive rate, $400 or $500 per terabyte. Be aware that neither of those things are perfect out-of-the-box solutions for you. They're good storage, but the question of management still leaves some work on your end. And there are many others. If you get online and look for cloud storage services, you'll get everything from sort of personal computer backup systems like Mozy or Backfire or Carbonite to, we were talking actually about Rackspace, is a company that InfoPeople uses for some of its data storage. There are lots of competitors in this space, but their prices tend to be fairly consistent with one another. And again, all of them will offer you excellent day-to-day uptime, but it's important to think about what your plan is beyond this particular provider at this particular moment in time. Finally, just to touch on the pros and cons of outsourcing, because that's one of the important decisions you'll have to make in storing and maintaining files in the current and near future. One is that you can pay for what you need when you need it by outsourcing your storage needs. And this is what you'll hear people in the industry talk of when they talk about scalable storage. That's really all they're saying. That is, you don't have to buy 50 terabytes now, planning to fill it up over the next 2 or 3 or 4 years. You can just buy what you need now, and when you need more, add another 15 cents a gigabyte to your bill. You do pay for some sort of overhead and common denominator services. So a system like Amazon will offer you better than 99.9% uptime and access to your files. That's very important if the job of your archive is to constantly be serving digital content to users the way that people would use files through your website. For a dark archival storage project, 90% uptime is probably more than you need. You may be touching those files once every year or two, and probably what you'll be doing is just verifying their integrity, but you'll still pay for the services that everybody needs. Outsourcing parts of your storage also reduces the needs for some kind of in-house expertise, and of course, people are expensive. If you don't have people with this skill set, outsourcing can be a real valuable way to take advantage of it. But also, still left on your plate is making a content connection between the repository, the place you're storing your files, and your access system, that is the system that you would use to actually deliver content to the users. And that's an important task to keep in mind. Finally, before we take some time to do questions, I just want to touch on this. This is something that was developed in the Cornell Digital Preservation Management workshops, and those are now run by the ICPSR. And it's just, I think, a good reminder to think about these 3 pieces of the digital preservation project. One is your digital assets, and in the even-numbered webinars in this series, text and image in the number 2, and coming up in number 4, audio and video, we've really been talking about what makes a useful, viable digital asset. The other pieces are the organizational infrastructure. What kind of organization are you in? Are you a historical society, a museum, a library? Do you have a dozen people working with you on IT issues, or do you have one, or do you have half of a person? Understanding the size and scope of your organization should help you think about how large a question you need to ask about digital preservation. Likewise, your technological infrastructure. Are you sitting at a Carnegie Tier 1 research university with access to big data services, or are you at a local public library's history and genealogy room? and similarly your resources frameworks. This is going to cost some money to do, and if your money comes regularly versus if your money comes through occasional grants and gift funding, you need to think about how that will play into your plans for long-term maintenance. So with that, we're at about quarter till, and I want to turn it over to you for Q&A. I see one question here, and you can enter questions into the Q&A panel, and I'll begin to respond to them. I'll also remind you these webinars are archived on the InfoPeople website, and I've given a persistent URL, or at least as an alleged digital preservation expert, I hope that will be a persistent URL to my own website, where I post follow-up to these conversations. Sometimes we get technical questions here that are better answered by referring you to a particular document or resource, and so those links and those questions, I try to post some follow-up on the web as well. So thank you, and I'll turn now to questions. One here about Content DM, and this is a good clarification. So if you're using a management system like Content DM, DSpace, some people are using something called Islandora, which is a Fedora repository with the Drupal content management system grafted onto it. If you're using those systems, the metadata that you've created and supplied is in fact adequate to provide access. The issue of on-your-own programming to be aware of in this question of storage and maintenance is sort of how that system for creating all of your metadata and collecting files plugs into the repository system. So making sure that that metadata has a sort of independent existence or a way to be exported that doesn't depend on Content DM or, for heaven's sakes, on your Access database. You want to make sure that your metadata can live outside of its current system, because 5 or 10 years from now, you may not be using Content DM or you may not be using Access. The question here about PDF and PDFA, most PDF products now support PDFA conversion. In fact, even the current version of Microsoft Word has a slightly problematic, but far better than nothing, PDFA export. The questions you need to ask in creating those files are whether they conform to the standard. And if you get online and start doing some web searches for PDF verification and validation, you'll turn up some things pretty quickly. Question about TIFF formats. This is a real smart question. TIFF is a broadly defined wrapper format, so you can in fact have a TIFF file that contains JPEG compressed image data, and in this case you're correct. I think the TIFF raw is what you would want to scan. So here's Connie has asked a great question about Blu-ray discs for durable storage. And Connie, I think it sounds like you're at the beginnings of a pretty sensible strategy in some ways. So the 12 terabyte hard drive is going to have has a lot of advantages just in terms of speed of reading and writing for it. And if you're creating 2 copies on Blu-ray disc just to have some backup, there's nothing wrong with that. And I think what you'll need to do is sort of pat yourself on the back for having thought through making multiple copies right now, and then think in 2 or 3 years, are your Blu-rays still readable? Are you getting such a pile of Blu-ray discs that recovering data from them would be a monumental task? I talked to a place once and they had, I think, something like 100 DVDs they would have to read back data from if they ever lost their primary master copy. And that was becoming unmanageable. But the Blu-ray disc in and of itself, it will certainly last for a year or 2 or 3. The thing to do is just to make sure that you're not counting on it for longer than its lifespan. This is a great question about cloud services and the Patriot Act, but I would, Brett, actually cast this wider. Be aware, the cloud is an abstract name. That cloud is actually a data center, and it's on some piece of sovereign real estate and subject to the laws of the country in which it resides. I don't offhand know of a Canadian data service provider. There's, but if you look around for Canadian ISPs, for Canadian internet service providers, I would expect that several of them provide essentially cloud-like data services. But yeah, the legal questions are important. A question here, can Online Archive of California or USC's digital library be thought of as trusted digital repositories, or are they simply vehicles for user access? I can't speak to USC's digital library. I don't know the technology behind that, that particular service. I suspect that they are lowercase trustable digital repositories. That is, knowing some of the people who are working on those systems, they're smart people and they're doing good work. In terms of being certified repositories, that's a little bit of a separate question, but I don't think that's the primary intent of this question. I would caution you to think, and I think your question shows this, to distinguish between sort of the user access and the repository and long-term management end. So Online Archive of California has a lot of material that it makes available to people. What really sits behind that are the California Digital Library's California Curation Center, and they run a repository called Merit and have a number of things they call microservices that are sort of individual one tool, one job preservation services that are used to manage that content. And so there's a repository layer that sits behind that. And I suspect if you go to USC, certainly if you go to Online Archive of California, and you ask those questions, you know, what's the repository behind this, you'll pretty quickly get answers about how they're actually managing that content for the long term. Oh, great. Yeah, Adrian Turner's posted a note in chat clarifying OAC, the Online Archive of California, is an access system for digital objects and finding aids. And again, California Digital Library, which is a UC system office, has another group, the University of California Curation Center, that deals with the repository maintenance questions. Question from Dara, how do I find out what the smallest in-collection personnel trusted digital repository is? Are TDRs all located at large institutions? I should say here, and I apologize, I was probably not clear about this when I touched on it earlier, certification of trusted digital repositories is very new. There have been actually only a couple of sort of full-blown certifications conducted, and most of those are in fact kind of either large institution or large third-party things like Portico or Laux. There are lots of small, trustworthy digital repositories, though, that are operated, and lots of institutions have pretty sound data management practices. So if you're looking for really for certification, you have a pretty short list to draw from. A question about my impressions of Archivematica. Archivematica is a digital preservation, how to describe Archivematica? sort of service or system approach, and it uses this microservice architecture that I mentioned. California Digital Library has been very involved in creating this system. I haven't spent a lot of time working in Archivematica, so I've kind of read over their technical documentation just as everybody else does. And they've done a very thorough, thoughtful job of thinking about what's involved in managing content over the long term. Be aware that for Archivematica to be useful, it still has to plug into a storage system. That is, there has to be some hardware behind it. And just like anything, you need to make sure that that hardware achieves multiple copies in multiple places. And as with all open source software, it's sort of only as good as your programmers and local support. But I don't mean that to in any way cast any aspersion on them. I mean, they've done a tremendous amount of work creating a very thorough set of tools for digital preservation. It's really one of the kind of exciting things that's going on right now. I'll emphasize again, as I have throughout these webinars, I think it's very important in preservation thinking to have some sort of sets of timelines, some sort of horizons or kind of orders of magnitude of time in your preservation planning. And the first question is sort of always what you need to be doing right now, this fiscal year, to make sure your content is safe. And for some institutions, that may mean, we hand it off to our giant digital repository system that the university runs. For others, it may mean we write it to our Thunderbolt hard drive and we make 2 copies on Blu-ray discs. Both good for now. The second is to sort of think about the near term, the next couple, 5, maybe 10 years, and doing the assessment of, is the current technology, is what you're doing now sustainable and useful and reliable over that time? And in that case, systems like Archivematica and a good hardware RAID array really are. Thunderbolt drives and Blu-ray discs in tandem will start to be unsustainable. And then where the things like Archivematica and these really robust digital preservation systems, Fedora, DuraCloud, and the like, really have their merits is when you start looking out into the long term, beyond what you'll be doing over the next 5, 10 years. And when you start thinking about, gee, when I retire from my job, what am I handing off to someone else? And having things in a really well-managed system really starts to pay dividends at that point. And then I give certainly high marks to Archivematica for the work they've done there. Likewise, LOX has, in some ways, some of the most longevity in our field. LOX has been at this well over a decade. So about the time the internet got interesting, LOX started to develop. Fedora likewise has more than a decade of track record behind it as a repository management tool. So there's some real time testing there. Looking at the clock, I think we have about 4 or 5 minutes left. If you have other questions, please post them, and I'll try to answer them now. If not, I'll also make sure to post some follow-up. I think some links to some of these systems people have mentioned would be good to post, and I can follow up by posting those on the web.